In episode 33, titled 3.2 Use Central Tendency Measures, Mean, Median, Mode for Quick Insights, the focus is on how a simple average can either clarify reality fast or send an analysis off course with false confidence.
Central tendency measures are popular because they compress many values into one number, which is exactly what busy stakeholders want when they are scanning performance, risk, cost, or customer behavior. The caution is that compression always discards detail, so the measure chosen must match the shape of the data and the decision being supported.
When the wrong measure is selected, the number may still be computed correctly, yet it represents the dataset poorly and encourages the wrong interpretation.
The aim here is practical judgment, choosing the right center, explaining it plainly, and knowing when a single center is not enough.
Averages help because they provide a stable anchor for comparison, especially when a dataset is too large to reason about value by value. A single center lets two groups be compared quickly, such as one region versus another, or 1 month versus the prior month, without forcing the audience to parse an entire distribution. The same convenience is also the risk, because one number can hide important structure, such as extreme values, missingness patterns, or separate subpopulations that behave differently. Averages mislead most often when people assume the center represents a typical individual case, even when the data is skewed or mixed. The professional habit is to treat central tendency as a first pass that points attention, then confirm whether the chosen center truly matches how the data is shaped. The mean, commonly called the arithmetic average, is most useful when values are balanced and roughly symmetric around a central point. Symmetry means the low side and high side are similar in magnitude and frequency, so the mean lands near where many observations cluster. In that setting, the mean is efficient because it uses every value and reflects small shifts across the entire dataset, which makes it sensitive to gradual changes. It is especially helpful for quantities that behave additively, such as average temperature, average cycle time when outliers are controlled, or average score when the scoring system is designed to be linear. When the distribution is well behaved, the mean gives a clean summary that aligns with intuition and supports straightforward comparison across time and across groups. The median becomes the safer center when outliers distort the mean strongly, because the median is the middle value when observations are ordered. This makes the median resistant to extreme highs and lows, so a handful of unusual values cannot drag it far away from what most observations look like. In many operational datasets, outliers happen naturally, such as unusually long service times, unusually high purchase amounts, or unusually large file sizes, and these may reflect rare events or measurement defects. When those extremes are present, the median often better represents the typical case, which is what many stakeholders assume an average means in plain speech. The median also stays stable when a dataset has a long tail, which is common in human behavior and financial data, where a few cases dominate the upper end. The mode is most useful when the data contains common categories or repeated values, especially when numeric centers do not capture what matters. For categorical data, the mode is the most frequent category, which can quickly answer questions like which error type appears most often or which channel drives the most signups. For numeric data with repeated values, the mode can describe the most common observed value, such as a standard price point or a commonly selected rating, though it may be less stable when values are highly granular. The mode can also help when a dataset is discretized, such as when values are rounded, bucketed, or recorded in fixed increments that create meaningful repeats. The key limitation is that the mode describes frequency, not magnitude. So it should be used when most common is the right story, rather than typical size or typical amount. Comparing central tendency measures across groups can reveal meaningful differences faster than complex modeling, provided the same measure is applied consistently. When one group has a higher mean and a higher median, the shift is usually broad and affects many values, which supports a narrative of systematic difference. When the mean shifts but the median does not, the difference may be driven by a small subset of extreme cases, which suggests either a genuine tail behavior or a data quality issue like duplication or unit errors. When the median shifts but the mean barely moves, the group's typical experience changed while extremes stayed similar, which can happen when process improvements reduce typical wait times but rare delays remain. These comparisons become powerful when paired with context about who is in each group and whether the groups are comparable in size, collection method, and time window. Skew is the shape property that often explains why the mean feels too high compared to what most cases look like, and recognizing skew is a key skill for quick insight. Right skew means a long tail extends toward higher values, which pulls the mean upward because extreme highs contribute strongly to the arithmetic average. Many business measures are right skewed, such as revenue per customer, time to resolve a ticket, or number of events per user, because a small number of cases can be much larger than the rest. In a right skewed distribution, the median typically sits below the mean, and that gap itself is a clue that the tail is influential. When skew is present, the analyst should be cautious about presenting the mean as typical because it can be more accurate to describe it as average level across the whole population, while the median represents a more typical individual case. A salary example makes the median's usefulness feel concrete because compensation distributions commonly have strong right skew. If most employees earn within a narrow band, but a small number earn much more, the mean can rise sharply even though the typical employee's salary is unchanged. In that setting, reporting the mean as the average salary can unintentionally imply that most people earn near that figure, which can create confusion or distrust when it conflicts with lived experience. The median, by contrast, lands near the center of the employee distribution and often matches what people informally consider typical. This does not make the mean wrong, because the mean still represents total payroll divided by headcount, which can be useful for budgeting and cost planning. The professional point is that different centers answer different questions, so selecting the median for typical employee experience and the mean for overall cost level can both be correct when framed properly. Multimodal distributions deserve special attention because they can hide separate groups behind a single center, even when the mean and median look reasonable. A multimodal distribution has more than one peak, which often indicates the data combines subpopulations with different behaviors, such as new users versus experienced users, free tier versus paid tier, or automated versus manual processing paths. In those cases, a single mean or median can land in a region where few real observations exist, creating a center that is mathematically valid but practically unrepresentative. The mode can reveal this structure when it shows multiple common values or when the most common value differs sharply from the mean and median. A strong response to multimodality is segmentation, where the dataset is split along a meaningful boundary and central tendency is computed separately, so each group's typical behavior is represented honestly. Central tendency should be paired with spread to avoid overconfidence because a center alone says nothing about variability. Two groups can share the same mean while having very different ranges, which matters when the decision depends on predictability and risk rather than on typical value. Spread can be described using plain ideas like how wide the values are, how often large deviations occur, and whether the distribution includes extreme cases that matter operationally. In many business contexts, the upper tail is where pain lives, such as the longest delays, the highest costs, or the largest losses, and a center without spread can hide that risk. Pairing center with spread also improves credibility because it signals that the analyst understands the difference between typical and guaranteed, and that distinction is often what stakeholders need to choose appropriate actions. Missing values must be handled consistently before computing mean, median, or mode because missingness changes the effective dataset and can bias results if it clusters. A null is not a zero, and an empty field is not automatically the same as an unknown field, so the analyst must decide which records are eligible for the calculation and why. If missingness concentrates in a particular time period, channel, or region, dropping missing records can change the population and make comparisons unfair, even when the calculation method is correct. Consistency also matters across groups because computing a mean after excluding missing values in one group but treating missing as zero in another group creates a comparison that mixes different meanings. A defensible approach states how missing values were treated, confirms that treatment aligns with the business meaning, and checks whether the missingness pattern itself may be driving the apparent central tendency shift. Results should be explained in plain language rather than statistical jargon, because the measure is only useful if the audience can interpret what it represents. A mean can be described as the total divided evenly across cases, which makes it intuitive as an overall level, but also explains why extremes influence it. A median can be described as the middle case, which helps listeners understand that it represents a typical observation even when a few cases are very large or very small. A mode can be described as the most common value or category, which maps naturally to questions about what occurs most often. Clear language also includes clarifying the unit and time frame, such as whether the center reflects per-day behavior, per-transaction behavior, or per-user behavior, because the same center can be interpreted very differently depending on unit of analysis. When explanation stays concrete, stakeholders are less likely to misuse the metric and more likely to ask the right follow-up questions. A quick sanity check on sample values helps validate central tendency calculations, because a computed center should make sense relative to a handful of representative observations. For a mean, it should be possible to look at a small set of values and confirm that the average is not outside the plausible range, unless there are known extreme values pulling it. For a median, checking the ordered values around the midpoint often reveals whether a sorting or filtering mistake occurred, especially when the median seems inconsistent with typical cases. For a mode, scanning the most frequent category or value confirms whether normalization and text cleaning were applied consistently, since small differences in strings can fragment what should be a single common category. Sanity checks also detect unit and type issues, such as a numeric field treated as text or a currency scale mismatch, because those errors often produce centers that are numerically valid but practically absurd.
A three-choice rule for picking a measure can be narrated as a simple decision habit that aligns measure choice to distribution shape and communication need. When values are roughly symmetric and extremes are not dominating, the mean is a strong default because it reflects the full dataset and responds smoothly to broad shifts. When the distribution is skewed or outliers are influential, the median is often the better typical case center because it resists tail effects and aligns with how people experience the process most of the time. When the goal is to describe what occurs most often, especially for categories or repeated discrete values, the mode is the most direct answer because it identifies the most frequent case rather than an average level. This rule becomes more reliable when it is paired with a brief check for skew,
a check for multimodality, and a reminder that the chosen center should be explained in plain terms that match the decision context.
Over time, the habit reduces the chance of presenting a technically correct number that tells the wrong story.
The conclusion of episode 33 sets a small practice calculation for today. Choose one field in a dataset you already trust and compute mean, median, and mode conceptually. Then decide which one best represents the story you need to tell. The practice works best when the field has a mix of typical values and at least a few higher extremes, such as transaction amount, response time, or number of events per user, because it will reveal how the centers differ. The goal is not to produce a perfect chart, but to rehearse the reasoning that connects distribution shape to measure choice, including how missing values are treated and whether groups should be compared separately. Once the center is chosen, explain it aloud in one plain sentence that includes what the number represents and what it does not represent, because that is the moment where insight becomes usable. Repeating this short exercise builds exam-ready instinct and workplace-ready clarity, since central tendency is one of the fastest tools for turning raw data into a defensible first conclusion. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.